Hello everyone and welcome to OST Live, a weekly broadcast on blockchain, brand tokens, and token economies. On this episode, we will discuss the OST Wallet recovery solutions available. We will discuss the technical challenges involved, how it works, and how businesses can implement OST Wallet features. And with us today, I have Chief Blockchain Strategist Benjamin Bolin and OST VP of Engineering Rachin Kapoor. Guys, thank you for joining us on OST Live.
Welcome. Happy to be here.
So let's start off with your roles in the OST wallets. Ben, I guess we'll start off with you. Can you tell us about your involvement and role with the OST wallet?
So from the beginning, when we started Open Simple Token, we knew that we needed a very strong answer here. That the user experience of mainstream applications couldn't be compromised if we wanted to help them integrate Ethereum tokens into their application. And so that has crystallized under OST Wallet. It's been a very broad effort over more than a year and a half by many. So it's very much an honor for me and Rachin here to represent it. But my role specifically in forming the OST wallet has been sort of largely from the smart contract side, trying to defend the principles that we want to uphold there, while at the same time trying to find that answer and how do we find a new way to provide that user experience, combining with the wallet SDK on the user's phone to really make this work. So I think my interest mostly has been to preserve sort of the core principles of why we're decentralizing it and for the user to own the key. That's been sort of my defending angle on this.
Great, and we'll talk about that answer and that solution that OST has come up with. But now we'll go over to Rachin. You work directly with the engineering team in Pune. Can you tell us about your involvement with the formation of OST wallets?
So over the last 6 months, I've contributed in architecture, design, and security aspects of end-to-end flows, which include OST Wallet SDK, OST Platform, and a bit of protocol. I currently actively contribute to OST Wallet team that is responsible for the Wallet SDKs.
Great. So let's start off from from the top of explaining what is OST Wallet for the newcomers. In this specific episode, we're going to be talking about the OST Wallet SDK. So Rachin, can you explain what is OST Wallet and the OST Wallet SDK?
So the OST Wallet SDK enables end users to comfortably and safely interact with brand tokens within existing mass market mobile applications. So the developers can integrate the brand tokens into the app without actually compromising the user experience and take advantage of the OST's innovation such as wallet recovery. So OST Wallet has been designed for adoption of mass consumer applications, right? With this, users can set their 6-digit PIN instead and not just have to, which solves the problem of the 12 words. They are still encouraged to write down their 12 words, but there's also a 6-digit PIN that helps them recover their wallet if they're logged out. This PIN is also used for all critical features such as authorizing session keys and authorizing new devices. To further reduce the friction, what we have also done is we have started to leverage on biometric features. So users can also can give their biometric to also authorize a session on device, and it's not only dependent upon the 6-digit PIN. We have leveraged on 6-digit PIN in such a way that it is actually goes down till the blockchain level, which I think Ben would explain more in detail.
Great. So with this episode, we're keeping in mind this is a solution for hundreds of thousands of users. It is for applications versus a standalone wallet. But Rachin, let's jump into, you were talking about some of the solutions that OST has come up with. Can you tell us a little bit about the challenges of traditional crypto wallets?
So if you look at any mobile crypto wallet, because of security considerations, uh, the applications do not actually back up keys into the cloud. And that would mean actually you're trusting the cloud parties to securely hold your keys. So that's one of the challenge. The traditional wallet encourages user to write down 12 words, which can create friction on onboarding, and especially considering the consumer applications. Now we talk about a 6-digit PIN solution, but in reality, uh, if it's just a 6-digit PIN, it can be easily brute forced. So we had to come up with a solution that's really, really secure, right? Uh, Now, trusting any party is not in line with blockchain principles. So you cannot really expect companies like OST and our partner companies to become custodial of the keys. So we had to come up with a solution where the keys still remain on the device. And if the device is lost, it is still very easily possible for the user to recover it in a very secure manner.
Great, and yeah, we'll go over some of those solutions here. But yeah, as Ben mentioned, the focus is that, as Ben mentioned earlier, OST can't hold users' keys. This is one of the features of this, is that it's non-custodial. So let's talk about a little bit about the solutions. You already talked about recovery pin. And let's jump into some of the recovery options. Can you tell us about what is the delayed recovery method? Just a brief overview.
So as I mentioned, the 6-digit PIN can be easily brute forced, and it's really a weak entropy party when it comes to user. So, but if you look at the whole end-to-end system, there are three parties involved. There's the consumer application, there's the user, and then there is and then there is OST. So what we do is we leverage on the two high entropy parties, that is the consumer application along with OST, that would provide in stronger pieces of the password like salt and a password prefix that then when taken along with user pin is used to generate an actual of a hash which then is converted into an Ethereum key. Now this key, the address of this key goes down till protocol and ultimately goes into the multisig contract, which we have written our own add-on to that contract, wherein which allows that a signature from this key along with OST's signature would allow the ownership of multisig contract to be changed only after 12 hours. So what it means is even if the user's PIN is compromised in some other way using the login and stuff, user still has a period of 12 hours where they can go and stop this recovery process, and then they can also further reset their PIN and secure their wallet again.
Great. So the key reason for that 12-hour delay is if there is a compromise of a user's credentials, then they can do something within 12 hours. Is there sort of a side question? Maybe Ben could jump into this as well. Is there a reason why it's specifically 12 hours?
So the 12 hours is changeable, but but it protects both parties. So the contract itself enforces a 12-hour delay, which allows the user to be notified, but also would allow us to, as OSC, as the recovery controller, the time to respond should there be a breach of the systems at any place. Then we can pause it on the blockchain itself, or even abort it on the blockchain itself. So the 12 hours there are sort of a balancing between the hardness of the cryptography to break, which is above 5 months per key if both the mainstream application services are hacked and OST is hacked at the same time. Then for each user, the attacker would have to spend 5 months plus to brute force any of the recovery keys. If he does that 5 months brute forcing of a single account when he has hacked both services, then it's still delayed with 12 hours. So if there is suspicious behavior, either the user or we could cancel that on the contract. And so we, from that perspective, we are very comfortable that the cost for hacking any of the accounts through the recovery mechanism is orders at least 100 times bigger than any of the amounts users would hold within mainstream applications. So we estimate that most users would hold 100, maybe a few thousand dollars worth of value within a normal mainstream application max. And the cost of breaking any of those accounts now is at least 100 times higher than that cost. If, however, someone would want to hold more than $1,000 or a couple of $1,000 in the account, they should disable the recovery feature, for example. But that is because it's as Rachin explained, it's an add-on to the multi-sig contract where the user really owns the value on the contract. He or she holds all the keys. This recovery mechanism is only used in the case where the user has lost all the keys that were accessible or registered in the multi-sig contract.
Rachin, we'll go back to you and we'll move on. We'll come back to Ben on sort of what goes on in the back end of these recovery methods. But before that, let's cover one additional feature of the OST Wallet SDK, which is being able to access a wallet on multiple devices. So I'm going to pull up this image here. And Rachin, if you can sort of walk us through what's going on here and what this process means.
Okay. When there's a consumer application and you integrate the wallet SDK, the SDK does all the key management for you. So it creates a key, it encrypts it, and keeps in your device in your device in a very secure manner. Now, one of the ways to authorize device is, so if you already have an existing device and you want to use another device, there are two ways basically that you can do it instantly. First one is you could, as soon as you set up your second device, there is a device key address that is generated. And then you could use your first authorized device to scan a QR code that will authorize the second device. And this would happen almost instantly as soon as the transaction is mined on the blockchain. The second way could be that you can, if you have noted down your 12 words of your first device, you can use those 12 words and put it into the second application, which would then temporarily generate the device key of the first device, authorize the second device, and then that key itself is removed from the second device. So these are the two major ways by which you can authorize devices. Now, there are different aspects to it. So when we say a multisig, what we actually, in this diagram, that is referred as a device manager. So a device manager is a multisig contract wherein you have multiple owners, which can then be, and more owners can be authorized by reaching a certain requirement. So for our use case, the requirement is primarily one, wherein any device can authorize another device, right? So these keys get, the address of these keys is registered into the device manager, which is the actual controller of the token holder. So if you have to create a session key, it has to be a device manager operation, which would then add a session key to the token holder. And then the session key can perform transactions on your token holder. So, so on both devices, now that you have authorized keys, what you would want to do is if you can create a session key with certain spending power for a limited amount of time. Once you have done that, you can start doing the transactions, submitting the transactions to a relay service, in our case, that is OST, which can submit these transactions to the correct token holder on the blockchain, and hence your tokens would be transferred to the intended party. Now, there's also the delayed recovery aspect. I think we already covered on that.
Great, and you said there's the possibility to add spending limits to session keys. So are these spending limits set by the application developers?
Yeah. Currently, I mean, they could expose this to the user, but currently, I think we recommend them to set this to default reasonable values depending on their application. And specifically, like we recommend that the session keys are valid for 2 weeks, so that this 6-digit PIN, which is very important for the user to remember in case she needs to recover, that we do refresh memory on a somewhat regular basis. And so we recommend 2 weeks for the app developers to ask the user to reauthorize the keys.
And now we'll go over these recovery mechanisms. I have 3 here, but you can correct me if there's more ways of recovering access to your lost wallet. The first one is the recovery PIN. Then we have the 2 optional methods, which is authorizing a new device and the mnemonic phrases. So Ben, can you explain a little bit about each recovery method and the pros and cons of each, and sort of the requirements of the PIN and the option, and when it would make sense to add that option for the users?
Yeah, so if you can pull up there's an image associated here as well, I think. But the story we started from, and now that's still very much the ruling paradigm, is so when we talk about decentralizing value or tokens, we really talk about decentralizing keys, which brings with it some inevitable responsibility. The user needs to take some responsibility, but it also needs to be plausible for the user to really take this responsibility. And most apps right now really do still force you to write down 12 words, which is not a good user experience, not at the beginning of starting the application, but also not at a later point, because mainstream applications do not have a desire to educate their users about core cryptography. And so it's very hard to explain why you would need to use 12 words to own your money. That is just not going to scale to millions or tens of millions of users. So this was a hard requirement that we set ourselves 1.5 years ago. What we did agree on as a barrier for ourselves was that users can remember 6-digit PINs. We've all gotten accustomed to that with the iPhone, where by default now it uses 6 digits to lock your phone. But as Rachin already explained, that's not a secure key. Why, when the user creates a new account, when he opens the app for the first time, we do ask him to enter a 6-digit PIN and then reconfirm that 6-digit PIN. And then, as we explained with session keys, every 2 weeks, you need to reauthorize your session if you haven't already, which also requires you to access these device keys, which you can only get to with the 6-digit PIN. If we don't force the user to write down 12 words, which inevitably is really what is required, then we need to be able to, in a secure way, leverage this knowledge of 6-digit PIN when he would have lost all the devices. So in this case, how we've solved this is by introducing 2 new secrets, because we have a unique setup where the application already authenticates the user with a user login and a password, and we relay transactions from the user to the blockchain on behalf of the application. And so those two secrets are separated, but even if they are combined, they're still not enough to know the recovery key. And so this recovery keys is separate from the device keys in that it allows you to set a new device key with this recovery key. But you can only do so after the delay on the contract, as we explained.
Great. So going back to the pin for a second. So it is. Can you cover again what is used? I guess on the back end to recover access via pin. It's not just a pin. So it's something from the application side, something from OST, and then obviously the 6-digit pin from the user.
Correct. And so those two secrets, so the salt from OST Platform and the let's call it the credential information, but some hashed information from that the application holds for the user, those are sent to the phone, right? Where they are recombined in the only in the phone are they combined together again. So we don't know the secret information from that the application holds, and the application doesn't know the salt that we hold for the user. But when they are recombined in the phone of the user, then it still requires a 6-digit PIN. And then we ask the phone to do a very intense computation. That's an intense computation if you know the 6-digit PIN. If you don't know the 6-digit PIN, that's an almost super expensive computation. You'd need a server farm for 5 months to try to reverse that computation if you don't know the 6-digit PIN. But the user, if hopefully does remember it, and then his phone in about a second can regenerate this recovery key, which then allows to sign for a new device key. But the contract will still delay it with 12 hours. So even if a hacker manages to breach both the application and OST as a relayer independently, and brute forces a single account, then still you need to submit this to the contract. And at the contract level, both the user can abort this if he wouldn't have requested this change of device, or we can abort it if we see behavior that we didn't see as correct behavior.
Great. So these things are combined it's combined in the enclave of the phone.
Well, the enclave, so technically speaking, but Ratchin knows this more precisely. The enclave is either on iOS a hardware feature or on Android a software feature by the operating system, so a level below the application running on the phone. That securely manages these device keys, and so or session keys also. But all key management we handle in the secure enclave of the phone, and then the secrets are combined in the application of the phone, not specifically in the secure enclave.
Can a user recover access, say if there is no mnemonic seed phrase set up and they lose access to their PIN? What was the option?
So then there isn't an option, right? So this is the cold hard truth, but and this is the starting story, right? The user does need to take some responsibility, and so we've worked very hard to make that a manageable responsibility, because we ask the user to remember the 6-digit PIN, or additionally also write down the 12 words, or have multiple devices, for sure. But that is the minimal effort we require. If that isn't the case, then we can't recover. And so we obviously this also depends on the maturity of the user, because there will be a long tail of many users who have maybe $5 in their account as we scale to millions of users. They if they lose their 6-digit PIN, they might just lose that money. But as you hold more money in the account, then you might be encouraged to write down the 12 words or take stronger measures.
Great, and that's so we cannot stress that user needs to take the pin very seriously, but also one of the beautiful things about this is that the user does own what they hold. So we'll get into I guess next we'll talk a little bit about what were some of the major challenges to accomplishing this. This is something that took over a year of work from concept to now today. This is something that a new business can go on OST Platform. They can sign up. They can first create their brand token and then implement the OST Wallet SDK. So Ben, what were some of the major challenges in creating these solutions for OST Wallet?
I mean, they were plentiful. We've definitely iterated over many different ideas before we sort of found this sweet spot. It took a lot of hard pressuring by Jason Goldberg, our CEO. He always came back with like, no, it has to be a 6-digit PIN, and we would come back with, no, we can't achieve it, and then he would send us back, and we iterated countless times. But the importance of it is that now it's all it's not just that it's a 6-digit PIN recovery, which makes it easy for the user. It is additionally also very easy for, or relatively speaking, it's very easy for the developer, because what the SDK does is securely manage different types of keys in the background for the application developer. He doesn't really have to think too much about it anymore. I can maybe give it to Rachin to elaborate a bit.
Right. So when we talk about the Wallet SDK, the primary function is that it creates and manages different type of keys. So there are basically 3 type of keys that it creates. One is the API key. This API key is used for signing requests that are sent to the OST platform, and the OST platform can then authenticate based on signature whether the user is who they claim, right? And this key as well sits on the device along with the keys. The second key is the device key, which is used to perform all device manager operations or multi-sig operations, like authorizing other devices, creating sessions, revoking sessions, revoking devices. And the third one is the session key itself. All these keys are created using the standard protocols. So what we do is we randomly generate 12 words for all of them using BIP39. And then using BIP32, we create SD wallets out of it, and then we obtain the SD key out of it, which is actually used for the operations. Now, what Secure Enclave does is, how we leverage on Secure Enclave is, these keys are not kept in clear text. It would be a great security hazard if we do that. So we encrypt this data using Secure Enclave. Now, Secure Enclave is a piece of hardware on your mobile which can securely encrypt data without any other monitoring application or any other software on your mobile to detect the plain text that is being encrypted. And during decryption as well, the decryption also happens inside the hardware itself. So we encrypt these keys and keep it in Secure Enclave and encrypt these keys, and then we store it on a keychain in case of iOS and a SQLite database or Room database in case of Android. So that's how we leverage on Secure Enclave. One of the common questions that we get around is Secure Enclave itself supports creating and leveraging on keys, but the problem is that it doesn't really support Ethereum kind of keys. So that's why we have to leverage in best possible manner over there. Now, coming to the implementation part of it, the implementation, so how it really works is you, each flow is called a workflow. So you've got different kind of workflows. For example, there's a registered device workflow, because initially the OST kit does, or the OST platform doesn't really know if the device is authenticated or not. So we would require the assistance of the authorizing party, that is our business partners, that can tell us for this user, this is a particular address from which you'd be getting the API requests. So that workflow itself is called the register device workflow. Then we've got activate user workflow, in which the SDK directly sends the inputs to the OST platform server, which then deploys the three contracts: the token holder contract, the multisig contract, and the add-on recovery contract. Then other operations such as authorized sessions and authorized device, we have got very simple APIs in our SDKs in which you just have to put in the values, and the SDK will take care of generating the transaction, the data of the transaction, and signing it and then sending it over to OST platform. One of the key things when we have talked so much about delayed recovery is that uh, there are server-side SDKs as well, but the server-side SDKs are not allowed to access the salt part of the user's secret or the recovery key. It's only this wallet SDK key that can actually request for the salt when it needs to recreate the PIN. And then there are, speaking of PIN, there are other APIs such as reset PIN, so you can actually provide your old PIN and new PIN and then rotate it. And obviously there's recovered device. And the main thing of it is we also have a transaction. I always keep missing it out, but we also have a transaction API using which you can transfer your brand tokens to other users. To keep the implementation simple, so we define these methods which can be easily invoked by the developers, but at the same time, we also give them one simple callback interface. Now, what this callback interface does is it enables communication from SDK to the application and vice versa. So if SDK needs a pin, it gets a callback using these interfaces to the application. Application can then they have their own custom UI to get the pin from user and then send it to the SDK. And SDK keeps updating the app about various states that would happen. For example, if request has been acknowledged by OST platform, we give a callback called request acknowledged, and then we have flow interrupted if there are some errors that have occurred. That could be because of invalid user input or invalid kind of operations. And finally, we have flow completed, that is received when the transaction is actually mined on the blockchain. So this simple interfaces help developers to easily integrate with the SDK, and they don't really have to worry about key management, but they have to be vigilant in the sense that they do not include any kind of third-party malicious code within their application, because a malicious code in the application can then easily break all the security things.
Great. And implementation is made very, very seamlessly. These app developers are already familiar with implementing SDKs and APIs. But now as we conclude this episode, so now
I wanted to actually highlight this and it came to mind when Rachin was speaking. While one important objective here also is that these contracts that we've outlined in this episode and then the SDK, in order to talk to these contracts, actually allow you to write any Ethereum smart contract on the chain. So they are meta transaction contracts. So the contracts themselves don't say what happens with your token. Rather, they only protect the user's account and tokens that the user has and connect it to the phone but it's a general architecture. So as a developer, you can write any smart contract that does whatever stateful behavior, whether it's NFTs or some reputation mechanism that interacts with your token. All of that is possible, and you can leverage the same SDK and contracts that we described here. All of this code is open source. We have developed it in public, and we will keep updating it in public. It's free open source license. And we've also expended a lot of effort on having it audited, all parts of it, the SDK, the backends, the cryptography of it, the contracts. It has been audited, and we will keep auditing all future versions of it. Also, the development of and the review of the cryptography has been done in collaboration with academics. And so it's quite a lot of effort that went into making this usable tool set for developers.
Absolutely. And for the listeners, all the links to this episode discussed today, OST has an amazing suite of developer resources available to learn more about it and everything there, including video tutorials will be linked down below. Ben and Rachin, thank you so much for joining us on this episode.
Thanks, Jose.
Thank you.